next question is find the local maximum and local minimum if any of the following functions. Also find the corresponding local maximum and local minimum values. We have to find points of local maximum and local minimum and the corresponding local maximum and local minimum values. So here we are given fx is equal to this much. We find the first derivative f dash x. F dash x is first function into differentiation of this. Differentiation of this is x plus 1. First function differentiation of second plus second function into differentiation of first. This will be 3 into x minus 1 whole square. Differentiation of x minus 1 is 1. So this is equal to, now x minus 1 whole square is common and x plus 1 is also common. So we are left with, now x minus 1 whole square is common, so we are left with x minus 1 into 2 and this is common. So x plus 1 is common, so we are left with x plus 1 into 3 into x minus 1 whole square is common. So this is equal to x minus 1 whole square into x plus 1 into, this will be 2x minus 2 plus 3x plus 3 and this is equal to x minus 1 whole square into x plus 1 into 2x plus 3x is 5x, 5x plus 1, 5x plus 1. So put f dash x equal to 0. Put f dash x equal to 0. So what we get is x equal to 1, minus 1 and minus 1 by 5. So these are the critical points or extreme points. So we have the points minus 1, minus 1 by 5 and 1. Now we solve this question first using second derivative test and then using first derivative test. We find the second derivative of this. Second derivative will be f double dash x is equal to, first differentiate this keeping these two as they are, then differentiate this, keep the other two as they are, and then differentiate this, keep the other two as they are. So this is the formula. You can see the side sheet. So first is x minus 1 whole square into x plus 1 into differentiation of 5x plus 1 is 5 plus x minus 1 whole square into differentiation of this will be 1 and we are left with 5x plus 1 plus next will be, we will keep these two as they are and differentiate this. So this will be 2 into x minus 1 into x plus 1 into 5x plus 1. So this is equal to, now simplify these. X minus 1 is common and we are left with 5 into x minus 1 into x plus 1. 5 into x minus 1 into x plus 1 plus x minus 1 is common, so we are left with x minus 1 into 5x plus 1 plus x minus 1 is common, so we get 2 into x plus 1 into 5x plus 1 and this is equal to x minus 1 into, this will be 5 into x minus 1 into x plus 1 will be x square minus 1. So this would be 5x square minus 5 and simplify this, we get 5x square. X into this is 5x square plus x minus 5x minus 1 plus 2 into this. X into 5x is 5x square. 5x square into 2 is 10x square. X into this is x. So multiply by 2, we get 2x. This will be 5x, multiply by 2, we get 10x. Plus 1 into 2 is plus 2. This is equal to x minus 1 into. This will be 5x square plus 5x square. 10x square plus 10x square. 20x square. Then collect the terms of x. X minus 5x is minus 4x. Minus 4x plus 2x is minus 2x. Minus 2x plus 10x is 8x. So this will be 8x. Now the constant term. Minus 5, minus 1. Minus 6. Minus 6 plus 2 is minus 4. So we have 4 into x minus 1. 4 is common. So we get 5x square plus 2x minus 1. Now we find the sign of f double dash at 1. Now first point we consider x equal to minus 1. So f double dash at minus 1 is equal to, this is negative, 4 into minus 2 into, this will be minus 1 square is 1, 5 minus 2 minus 3, 5 minus 2 minus 3 is 2. So this is negative. Therefore x equal to minus 1 is a point of local maximum, and x equal to, next point is minus 1 by 5. F double dash at next point is minus 1 by 5. So f double dash at minus 1 by 5 is equal to, now put minus 1 by 5 in this. Minus 1 by 5 minus 1 is negative. So we will have this is negative. This is negative, and 5 into minus 1 by 5 whole square is 1 by 5. This is 1 by 5 minus 2 by 5 minus 1. So this will be equal to, this is negative, this is 1 minus 2 by 5. Minus 1 by 5 minus 1 is negative. So negative into negative is positive. Therefore x equal to minus 1 by 5. Therefore x equal to minus 1 by 5 is a point of local minimum. X equal to minus 1 by 5 is a point of local minimum. Now for the previous sheet you can see the side sheet. Next point is x equal to 1, and f double dash at 1 is 4 into 1 minus 1. 1 minus 1 is 0. So this is 0. So second derivative test in this situation fails, and we shall use first derivative test. Now I complete the discussion for first derivative test. Now consider the point x equal to minus 1. X equal to minus 1. X less than minus 1 in neighborhood of these points. F dash x has the sign, in this neighborhood we will find the sign of f dash x. And similarly for x greater than minus 1, points of this neighborhood, we will find the sign of f dash x is this. Now for x less than minus 1. For x less than minus 1, the sign in this neighborhood will be same as throughout this interval, because this function is a continuous function. So for x less than minus 1, take any one point. Minus 2, minus 3, or minus 1.1, minus 1.2, you can take any point. So take any point minus 2 for rough calculation. So minus 2 minus 2. This is positive. We need not check the sign of this. Minus 2 plus 1 is negative. Minus 2 into 5 is minus 10 plus 1 is negative. So this is negative, and this is positive. So throughout the sign will be positive. The sign of f dash x will be positive, because at minus 2 this is positive. Minus 2 plus 1 is minus 1. This is negative. Minus 2 into 5 is minus 10 plus 1 is minus 9. So this is negative, this is negative. So throughout the sign is positive. And for x greater than minus 1, take any one point in this interval. Minus 1 by 4 is a point in this interval. So at minus 1 by 4, the sign will be, this is positive. Minus 1 by 4 plus 1 will be positive. Minus 1 by 4. Minus 5 by 4 plus 1 will be minus 5 by 4 plus 4 by 4. This is negative, minus 1 by 4. So this will be negative. So this is positive, and this is negative. So sign of f dash x will be negative. You can do the calculation in rough. So this is negative. So what we see is f dash x is changing its sign from positive to negative. From positive increasing to decreasing. From rising to falling. Therefore, x equal to minus 1 is a point of local maximum. From positive to negative. So in this problem, what we notice that first derivative test is shorter to use than second derivative test. So for this problem, we shall follow first derivative test. We shall use first derivative test. We shall prefer first derivative test over second derivative test. Now we take up the second point, that is x equal to minus 1 by 5. X equal to minus 1 by 5. Therefore, for x less than minus 1 by 5, in neighborhood of this point, we shall find the sign of f dash x. And for x greater than minus 1 by 5, we shall again find the sign of f dash x. Now minus 1 by 5 is minus 0.2. So in neighborhood of this point, we shall take any point in this interval, because the sign will remain same throughout this interval. So in neighborhood of this, we will take, this is minus 0.2, I will take minus 0.3. So at minus 0.3, f dash x has the sign, this is positive, this is 0.3. Minus 0.3 plus 1 is positive, minus 0.3 into 5 is 1.5. So minus 1.5 plus 1 is negative. This is negative, this is positive, this is positive. So overall sign is negative. So this will be negative. And for x greater than minus 1.5, this is minus 0.2. So take any point greater than this in this interval. Because in this interval, the sign will remain same. Sign of f dash x will remain same, because f dash x is continuous and f dash x is 0 only at these points. So sign of f dash x in this interval will remain same. So take any point in this interval, say 0. So at x equal to 0, sign is, this is positive, this is positive, this is positive. So sign of f dash x is positive. Therefore f dash x is changing its sign from negative to positive. As we increase x past minus 1 by 5, sign of f dash x is changing from negative to positive. That is from monotonically decreasing to monotonically increasing. That is falling to rising. Therefore, x equal to minus 1 by 5 is a point of local minimum, which is same as we concluded from second derivative test. X equal to minus 1 by 5 is a point of local minimum. Now last point is x equal to 1. x equal to 1. Now x less than 1 in points in, now at points in the neighborhood of x less than 1, we have to find the sign of f dash x, and for points in the neighborhood of x greater than 1, we have again to find the sign of f dash x. Now for x less than 1, now x less than 1, we had these 3 points. So for x less than 1, the sign in this interval will remain same throughout. Therefore, for x greater than minus 1 by 5, the sign will be same as for x less than 1. So we have already found the sign for x greater than minus 1 by 5, and it was positive. F dash x is positive. And for x greater than 1, take any point in this interval 1 to infinity, take any point. The sign will remain same. You can take x equal to 2. So at x equal to 2, we find the sign of f dash x. X minus 1 whole square is positive throughout, and x plus 1 is, at x equal to 2, it is 3. And 5x plus 1 at x equal to 2 is 11. Positive into positive into positive is positive. So what we note is that as we increase x past 1, the sign of f dash x remains unchanged. It is positive, it remains positive. So what we conclude is x equal to 1 is a point of inflection. So at this point, what we note is the second derivative test fails, but we can use first derivative test and conclude that x equal to 1 is a point of inflection. So in this question, I have illustrated you that we shall prefer first derivative test over second derivative test in this particular problem. In problems where it is easy to find second derivative test, we prefer second derivative test. But in problems where it is lengthy to find second derivative, we use first derivative test. Or in situations where the second derivative test fails, that is f double dash at a particular point is 0, we shall use first derivative test. Now I move on to the next problem. Next problem is find the local maximum and local minimum if any of the following function. Also find the corresponding local maximum and local minimum values. Now we are given fx is equal to this much, and we have to find the points of local minimum and local maximum and the corresponding values. Now what we do is we first find f dash x. F dash x is differentiate sin x. Differentiation of sin x is cos x, and differentiation of cos x is minus sin x. So this will be cos x plus sin x. We put f dash x equal to 0 to find the critical points. So this will be cos x plus sin x is equal to 0, and this implies sin x is equal to minus cos x, and this implies tangent of x is equal to minus 1. Tangent of x is minus 1, and this implies x is equal to, now in 0 to 2 pi, this is 0, this is pi by 2, pi, 3 pi by 2 and 2 pi. So in this tangent x is negative in which quadrants? In second and fourth. So we shall take the values from the second quadrant and fourth quadrant. Now tangent x is equal to 1 at x equal to pi by 4. Tangent x is 1 at x equal to pi by 4. So in this interval we will take the value pi minus pi by 4. In pi minus pi by 4, this will be negative, and at pi by 4 the value will be 1. So we will get minus 1. Tangent of pi minus pi by 4 will be minus 1. In this quadrant, we will take 2 pi, this is 2 pi minus pi by 4. 2 pi minus pi by 4. At pi by 4, the value is 1 and 2 pi minus pi by 4 will be in fourth quadrant. In fourth quadrant, tangent x is negative. This implies x is equal to 3 pi by 4 and x is equal to 8 pi minus pi by 4, that is 7 pi by 4. Now I will find the points of local maximum and local minimum using, first I will use the second derivative test and then I will use first derivative test to give you a clear understanding of both the tests. But in practical problems, you will either use second derivative test or first derivative test. So I will first attempt this problem using second derivative test. Now f dash x is equal to cos x plus sin x. See this as 1, this is 2. So f double dash x is equal to differential of cos is minus sin x and differential of sin x is cos x. So f double dash at this critical point, that is 3 pi by 4, this is equal to minus sin 3 pi by 4 plus cos 3 pi by 4. Now sin 3 pi by 4. Sin 3 pi by 4 is sin pi minus pi by 4. Now pi minus pi by 4 lies in second quadrant, so sin is positive and we get sin of pi by 4 and sin pi by 4 is 1 by root 2. So sin 3 pi by 4 is 1 by root 2 and cos of 3 pi by 4, cos of 3 pi by 4 is equal to cos of pi minus pi by 4. Cos of pi minus pi by 4. Pi minus pi by 4 is in the second quadrant. In second quadrant, cos is negative. So we have minus and this is even multiple of pi by 2. So we will have cos of pi by 4. So this is minus 1 by root 2. So what we get here is 1 by root 2 and cos of 3 pi by 4 is minus 1 by root 2. So this is equal to negative. This is minus 2 by root 2. This is negative. And therefore, x equal to 3 pi by 4 is a point of local maximum. This is a point of local maximum. Now I will discuss the same point using first derivative test. Now for x less than 3 pi by 4, we have to find the sign of f dash x, and for x greater than 3 pi by 4 in the neighborhood of these points, we have to find the sign of f dash x. Now for x less than 3 pi by 4, now we have these points. We have 3 pi by 4 and 7 pi by 4 and the interval under consideration is 0 to 2 pi. 0 to 2 pi. Now we have to take a point in the neighborhood of 3 pi by 4, x less than 3 pi by 4, and the sign will remain same throughout this interval. So this is 3 pi by 4. Take any point in this, say pi by 2. Pi by 2. At pi by 2, sign of f dash x is cos of pi by 2. Cos pi by 2 is 0 and sin pi by 2 is positive. Sin pi by 2 is 1. So sign of this in this interval will be positive. And for x greater than 3 pi by 4, take any point in this interval because the sign will remain same throughout. We have to consider only the points in the neighborhood of this, but we know that sign in the neighborhood of this point will be same as the sign in this interval. So you can take any point in this neighborhood. So we take x equal to, this is 135 degrees, so you take 150 degrees. Now at x equal to 150 degrees, sine of f dash x is sine of f dash 150 degrees. This is equal to sine 150 degrees plus cos 150 degrees. Sine 150 degrees plus cos 150 degrees. This is sine of 180 degrees minus 30 degrees plus cos of 180 degrees minus 30 degrees. And this is equal to sine of 180 minus 30 degrees is in second quadrant. In second quadrant, sine is positive. So we will have plus, and this is even multiple of pi by 2. Therefore, we will have sine of 30 degrees. And cos of 180 minus 30 is again in second quadrant. In second quadrant, cos is negative. So we will have minus, and since this is even multiple of pi by 2, therefore cos will remain cos of 30 degrees. And this is equal to sine 30. Sine 30 is 1 by 2 minus cos 30. Cos 30 is root 3 by 2. Root 3 by 2. And this is equal to negative. So this is negative. For x greater than 3 pi by 4, the sign is negative. So this is negative. So what we notice, as we increase x past 3 pi by 4, the sign changes from positive to negative. That is, the function changes from monotonically increasing to monotonically decreasing. That is rising to falling. Shape will be like this. So this must be a point of local maximum. Therefore, x equal to 3 pi by 4 is a point of local maximum. And local maximum value at this point is f of 3 pi by 4. And f of 3 pi by 4 is equal to sine of 3 pi by 4 minus cos of 3 pi by 4. This is equal to sine of 3 pi by 4. Now sine of 3 pi by 4 is, we have already found sine of 3 pi by 4 is 1 by root 2. And cos of 3 pi by 4 is minus 1 by root 2. So this will be minus plus 1 by root 2. This is 2 by root 2. This is equal to root 2. Local maximum value is root 2. Now we consider the next point. Now the other point is 7 pi by 4. So f double dash at 7 pi by 4. This is equal to minus sine 7 pi by 4 plus cos of 7 pi by 4. You can consult the previous sheet on the side sheet. This is equal to minus sine of 7 pi by 4. 7 pi by 4 is 2 pi minus pi by 4 plus cos of 2 pi minus pi by 4. So this is equal to minus, now sine of 2 pi minus pi by 4. 2 pi minus pi by 4 is in fourth quadrant, and this is even multiple. Therefore in fourth quadrant sign is negative. So negative is positive. We will have sine of pi by 4. And again this is positive in fourth quadrant, and this is even multiple of pi by 2. Therefore cos will remain cos. So we will have cos of pi by 4. So this is 1 by root 2 plus 1 by root 2 is equal to positive. Therefore x equal to 7 pi by 4 is a point of local minimum. Now we shall solve the same problem using first derivative test. So we consider the point x equal to 7 pi by 4. For x less than 7 pi by 4, in the neighborhood of these points, we shall find the sign of f dash x. And in right neighborhood of this point, we shall again find the sign of f dash x. For x less than 7 pi by 4. Now, we have these points. This is 3 pi by 4 and this is 7 pi by 4. Now for x less than 7 pi by 4, the sign is same as for x greater than 3 pi by 4. Now for x greater than 3 pi by 4, the sign of f dash x was negative. So this is negative. And we shall now find the sign of f dash x for x greater than 7 pi by 4. And these are the end points of the interval. This is 2 pi and this is 0. Now in this interval, we shall take any point. So 7 pi by 4. Now 7 pi by 4 is 315 degrees. So we take any point in this 315, we will take 330 degrees. So f dash x at 330 degrees. F dash x is cos x plus sin x. So this will be cos of 330 degrees plus sine of 330 degrees. This is equal to cos of 360 degrees minus 30 degrees plus sine of 360 degrees minus 30 degrees. This is equal to, now cos of 360 degrees minus 30 degrees is, in which quadrant does this angle lie? It lies in fourth quadrant. In fourth quadrant, cos is positive. So we will have plus. And this is even multiple of pi by 2. That is 90 degrees. 4 into 90 degrees. So cos will remain cos. Cos of 30 degrees. And sine of this will again, this will be in fourth quadrant, and fourth quadrant sine is negative. So this will be minus and sine will remain sine. Now cos of 30 degrees. Cos of 30 degrees is root 3 by 2. And sine of 30 degrees is 1 by 2. So this is positive. This is positive. So f dash x is positive. Therefore, the function changes its trend from monotonically decreasing to monotonically increasing as we increase x past 7 pi by 4. From decreasing to increasing. Therefore, this will be a point of local minimum. Therefore, x equal to 7 pi by 4 is a point of local minimum. And this is same as this. And to find the local minimum value is equal to f at 7 pi by 4. And this is equal to fx is sin x minus cos x. You can see the side sheet. This is sine of 7 pi by 4 minus cos of 7 pi by 4. This is equal to sine of 2 pi minus pi by 4 minus cos of 2 pi minus pi by 4. Now this is in fourth quadrant. In fourth quadrant, sine is negative. And even multiple of pi by 2, therefore we will have sine of pi by 4. Minus, this is in fourth quadrant, cos is positive. So we will have minus cos, even multiple of pi by 2, so cos will remain cos. This is equal to minus 1 by root 2 minus 1 by root 2. This is equal to minus 2 by root 2. And this is equal to minus root 2. So local minimum value at this point is minus root 2. Now I take up another problem. Here we are given fx is equal to this, and we have to find the local maximum and local minimum if any of this function, and also find the local minimum values and local maximum values. So we have to find the points of local maximum and local minimum, and also find the local maximum and local minimum values. I will again attempt the same question using first and second derivative tests, so that you can develop an understanding in which situation which test is simpler. So first is we find the first derivative. F dash x is equal to 4 sine cube x into differential of inner function. Differential of sine is cos x, plus 4 cos cube x, 4 cos cube x into differential of cos x is minus sin x. Now 4 sin x cos x is common. So 4 sin x cos x is common, and we are left with sin square x. 4 sin x cos x is common, and we get minus cos square x. But 2 sin x cos x is sin 2x. So this is equal to 2 sin 2x. And cos square x minus sin square x is cos of 2x. So this is minus cos 2x. So this is minus cos 2x. And this is equal to, minus is common. We have 2 sin theta into cos theta. That is sin of 2 theta. So this is equal to sin of 4x. 2 of 2x. 4x. Now we put f dash x equal to 0 to find the critical or extreme points. So put f dash x equal to 0. So f dash x is equal to 0 implies sin of 4x is 0. Now x lies in this interval. 0 is less than x is less than pi by 2, and therefore 0 is less than 4x is less than 2 pi. So we have to find the points between 0 and 2 pi at which 4x is 0. Now sin of x is 0 at this horizontal line. Sin is 0 along x-axis and cos x is 0 along y-axis. So at this x is 0, here it is pi, here it is 2 pi, 3 pi, 4 pi. Sin x is 0 at 0, pi, 2 pi, 3 pi, 4 pi, and so on. So in this interval, on this horizontal line, 4x will be 0 at 0, but 0 is not in this interval. It is strictly greater than 0. Then it will be 0 at pi. So 4x must be equal to pi. And then it will be 0 at 2 pi. But 2 pi is not within this interval. It is not inside this interval. So we will not take 2 pi. So there is only one point at which 4x is 0, and that is 4x equal to pi. Therefore x is equal to pi by 4. Now I will solve this question using both first derivative test and second derivative test, so that you can develop a clear-cut understanding in which situation you have to use which test. First I use second derivative test. We find the second derivative of this function. So second derivative from 2 will be f double dash x is equal to differential of minus sin 4x will be minus differential of sin is cos 4x, and differential of inner function, that is 4x, is 4. So we have minus 4 cos 4x, minus 4 cos 4x. Now we put x equal to pi by 4 in second derivative. So f double dash at pi by 4 is equal to minus 4 cos 4 into pi by 4. This 4 cancels and we get minus 4 cos pi, and cos of pi is minus 1. So this will be minus 4 into minus 1, that is 4. Cos of pi is minus 1 is equal to positive. So f double dash pi by 4 is positive. Therefore, x equal to pi by 4 is a point of local minimum. This is a point of local minimum because f double dash pi by 4 is positive. For positive, the point will be a point of local minimum. You can see the side sheet. And local minimum value at this point is equal to f of pi by 4. F of pi by 4, this is equal to sine 4 pi by 4 plus cos 4 pi by 4. And sine of pi by 4 is 1 by root 2. So 1 by root 2 to the power of 4 will be 1 by 2 square. So this will be 1 by 4 plus 1 by 4 and this is equal to 1 by 2. So local minimum value will be 1 by 2. Now I do the same question using first derivative test. In first derivative test, let x be less than pi by 4. Consider the interval in which x is less than pi by 4 in neighborhood of these points. This is the number line, say interval is from 0 to pi by 2. This is 0, this is pi by 2 and we have this point as pi by 4. So x less than pi by 4. In neighborhood of this point, left neighborhood of this point, the sign will be same as throughout this interval because this function is a continuous function in whole of this interval. F dash at pi by 6. F dash at pi by 6 is minus sine 4 pi by 6. 4 pi by 6, that is 2 by 3. 2 pi by 3 minus sine 2 pi by 3, that is 120 degrees. 120 degrees. Sine 120. Sine of 120 will be in second quadrant. In second quadrant, sine will be positive. So positive into negative is negative. So f dash x is negative. And in this interval, x greater than pi by 4, in neighborhood of x greater than pi by 4, sine will be same as at single point in this interval. So take any one point. This is 45, take 60 degrees. 60. 4 into 60 is 240 degrees. 240 degrees is in which quadrant? It is in this quadrant, third quadrant. In third quadrant, sine is negative. So this will be negative into negative. We are not interested in the value. This will be negative into negative. It will be positive. So f dash x is positive. So f dash x is changing its sign from negative to positive. That is falling to rising. That is monotonically decreasing to monotonically increasing. It is changing its sign from negative to positive. That is, the graph is changing its trend from falling to rising, monotonically decreasing to increasing. So it will be a point of local minimum. And this conclusion is same as we did from second derivative test. X equal to pi by 4 is a point of local minimum. It is a point of local minimum. Same. You can use either of the two tests. Discussion. Now, if in above question the interval is say minus pi by 2 is less than x is less than pi by 2, then what we have to do is, now f dash x is this much. We put f dash x equal to 0. So f dash x is equal to 0 implies sine 4x is 0. And now x lies in minus pi by 2 is less than x is less than pi by 2. And therefore 4x will lie in minus 2 pi is less than 4x is less than 2 pi. So we have to take the values of 4x which lie between minus 2 pi and 2 pi. Those values of 4x at which sine 4x is 0 and they lie in this interval. So what we do is we know sine theta is 0 on the horizontal line. So we will take 0 pi 2 pi and 0 minus pi minus 2 pi. Now 4x equal to 0. 4x equal to 0 lies in this. So we will take the value 4x is equal to 0. Second is pi. Pi also lies in this. So we will take the value pi. Next value is 2 pi, but 2 pi does not lie in this interval. So we will not take this value. In 0 to minus 2 pi, we have already taken this value. Next value will be minus pi. Minus pi lies in this. So we will take this value, minus pi. And next will be minus 2 pi. But minus 2 pi does not belong to this interval. So this will not be taken. So values of x that we have to consider are x equal to minus pi by 4. X equal to minus pi by 4, 0 and pi by 4. So we will discuss the above question for these values. At x equal to minus pi by 4, f double dash x. Say this equation as 3. From 3, f double dash at minus pi by 4 will be equal to minus 4 cos 4 into minus pi by 4. This is equal to minus 4 cos of 4 cancels, we get minus pi. But cos of minus theta is cos theta. So this will be minus 4 cos pi. And cos pi is minus 1. So this will be minus 4 into minus 1. That is plus 4. This is positive. And therefore, x equal to minus pi by 4 is a point of local minimum. And now I will use first derivative test to draw the same conclusion. You have to use only one. This is only for illustration, so that you can have a understanding of both. So first derivative test, x less than minus pi by 4 neighborhood and x greater than minus pi by 4 neighborhood of these points. The sign of f dash x. Now we have these points. In this discussion, we have the points x equal to minus pi by 4, x equal to 0, x equal to pi by 4, and interval given is minus pi by 2 to pi by 2. So this will be minus pi by 2 and this will be pi by 2. So x less than minus pi by 4. In neighborhood of these points, the sign will be same as at a single point in this interval. So minus pi by 4. Take minus pi by 4 is minus 45 degrees. So this will be minus 60. Take a point here. Minus 60. Sign at minus 60. F dash x. F dash x is a minus sign of 4x. So this will be minus sign 4 into minus 60. Sign of minus 240 degrees. Minus sign minus 240 degrees. Sign of minus 240 degrees will be equal to minus sign 240 degrees. Because sign of minus theta is minus sign theta. So this will be plus sign 240 degrees. Plus sign 240 degrees. So 240 degrees. 240 degrees is in which quadrant? First, second, third. It is in third quadrant. In third quadrant, sign is negative. So sine of f dash x will be same as sine of 240 degrees, which is negative. So this will be negative. This is negative. And in x greater than minus pi by 4, greater than minus pi by 4, take any point in this interval, because sign will be same throughout this interval. So take any point. Take minus 30 degrees. This is minus 45. In 0 to minus pi by 4, take any point. That is minus 30 degrees. So sine of minus 30 degrees. So this will be minus sine 4 into minus 30. That is minus 120 degrees. Sine of minus 120 degrees will be sine of 120 degrees. Because sine of minus theta is minus sine theta. So this will be plus sine of 120 degrees. And sine of 120 degrees is in which quadrant? This is in 90. It will be in second quadrant. In second quadrant, sine is positive. So this will be positive. So the sine of f dash x will be positive. Therefore, f dash x is changing its sign from negative to positive. That is from decreasing to increase, falling to rising. Therefore, this point will be a point of local minimum. Therefore, x equal to minus pi by 4 is a point of local minimum. And this is same as this. Same conclusion we are drawing from second derivative as well as first derivative. For other points, you can similarly complete the question. You can try it yourself.